Let's now discuss one of the first pieces in the pipeline puzzle, which is handling large volumes of streaming data that won't be coming in from a single structured database. Instead, those event messages could be streaming in from 1,000 or 1,000,000 different events, all happening asynchronously. A common use case where you see this pattern occur is with IoT, or Internet of Things applications. IoT devices could be the sensors on Gojek's drivers' motorcycles that you saw earlier that send out that location data every 30 seconds for every single driver. Or they could be temperature sensors placed throughout a data center to optimize and measure heating and cooling costs. Whatever the use case is, we have to tackle these four primary components. Streaming data from various devices or processes that may not even talk to each other, and even they could send bad data or data that's delayed. That's number one. Number two, we need to have a way of not only knowing and collecting these streaming messages in some sort of buffer, but also allow other services to subscribe to new messages that we're publishing out. Naturally, the service needs to handle an arbitrarily high amount of data so we don't lose any messages coming in. And it has to be reliable. We need all the messages, and also a way to remove any duplicates if found. One tool to handle distributed message-oriented architectures, like what we've been talking about, at a scalable way is Cloud PubSub. The name is easy to remember because it's the publisher-subscriber model, or another way of thinking about it is Cloud PubSub publishes messages to subscribers. At its core, PubSub is a distributed messaging service that can receive messages from a variety of different streams, upstream data systems like gaming events, IoT devices, application streams, and more. It ensures at least once delivery of messages and passes them to subscribing applications, and no provisioning is required. Whether it's a ton of messages or none at all, PubSub will scale to meet that demand. Also, the APIs are open, and the service is global by default, and offers end-to-end encryption for those messages. Here's what an end-to-end architecture could look like. Upstream data starts in from the left and comes into those devices from all around the globe. It's then ingested into Cloud PubSub as the first point of contact with our system. Cloud PubSub reads, stores, and then publishes out to any subscribers of this particular topic, we'll talk about topics soon, that these new messages are available. Cloud Dataflow, as a subscriber to this PubSub topic in particular, can then say, hey, you got messages? Let me take them. It'll ingest and transform those messages in an elastic streaming pipeline. And you can output those messages wherever you want. If you're doing analytics, one common data sink is Google BigQuery. And lastly, you can connect a data visualization tool like Tableau, Looker, or Data Studio to visualize and monitor the results of your streaming data pipeline. Next, we'll talk more about the architecture of PubSub. A central piece of PubSub is the topic. You can think of a topic like a radio antenna. Whether your radio is blasting music or it's turned off, the antenna itself is always there. If the music is being broadcasted on a frequency that no one's listening to, the stream of music still exists. Similarly, a publisher can send data to a topic that has no subscriber to receive it. Or the inverse. A subscriber could be waiting to hear data from a topic that isn't getting any data sent into it. And that's kind of like listening to all that static on a bad radio frequency. Or you could have a fully operational pipeline where the publisher is sending data to a topic that an application has subscribed to and is pulling from. To recap, there can be 0, 1, or many publishers, and 0, 1, or many subscribers relating to any given PubSub topic. And they're completely decoupled from each other, so they're free to break without affecting their counterparts. It's best described in an example. Say you've got an HR or human resources topic. A new person joins your company, and then this notification should allow other applications that care about a new user joining your company to subscribe and then get that message when it happens. What applications could tell you that a new person just joined? Well, you might have two different types of workers, full-time employees or contractors, Both sources could have no knowledge of the other, but still are equally pushing their events saying, this person just joined, into the PubSub HR topic. What other areas of your business do you think would like to know as soon as a new person joins your organization? Once PubSub receives the message, downstream applications like the company's directory service, the facilities system, account provisioning, and badge activation systems can all listen in and process their own next steps independent of one another. PubSub is that good solution to buffering changes from those lightly coupled architectures like this one here, with many different upstream sources and potentially many different downstream syncs or subscribers. It supports many different inputs and outputs, and you can even publish from one PubSub event from that topic to yet another PubSub topic should you wish. For our application, we want to get these messages reliably into our data warehouse. So now we're going to need a pipeline that can match PubSub's scale, and it has the elasticity to do it.